For those of you who do not know me personally, my name is Kathryn. I am a software engineer inside of the input-output engineering team. A little bit about me personally. I am a big history buff. I'm a big proponent of local community development initiatives, and I'm a huge foodie. If you would like to connect with me personally, here is a QR code. You can scan that, and that will take you to my personal LinkedIn page. If not, you can meet with me afterwards, and we can connect then as well. So, quick rundown of the agenda today. First, we are going to peer through the looking glass of time, and we're going to take a look at how did the software industry emerge in its very early days. And then we are going to analyze some of the events that happened over time that led to the development of the open source movement. This is a movement that has been around for nearly 30 years, and there's been a number of accomplishments that have been achieved by the open source initiative. So we'll go over what some of those are, and we'll start to analyze, is there any opportunities for how we can improve best practices around how open source projects are built and delivered. And finally, I'm going to give you a sneak peek of some of the ways that the input-output engineering team is thinking about how we can further double down on our commitment to accountability, transparency, and collaboration in terms of our open source ways of working. So before we begin, I want to get a quick feel of the room. How many of you are involved in open source projects or have previously worked on open source projects? Anyone, show of hands? We got a couple of hands here. That's great. How many of you in the audience are familiar with the history of the open source initiative and how this was formed? Any hands? No one? Okay, one person. We've got half a hand. Okay, that's great. That means some of you will learn some new things today, and as a former educator, I'm very excited about that. So let's jump into the meat of the conversation today. Before we begin, I would like for you to put on your imagination caps, and we are going to travel back in time to the 1950s and the 1960s, where our story began. During this period in time, the way in which people thought about software was vastly different from how they think about software today. Software was not seen as this unique product that had its distinct market value as something that was separate from hardware. The way people thought about software during this period in time is that software was seen as a feature that was used to help improve the way that hardware performed and how it functioned. And what would happen is that hardware manufacturers would develop this software, they'd bundle it with the hardware, and they'd essentially give it away for free as a value-added service. Now, today, software runs the world. Everyone uses software. There's tons of people who are involved in manufacturing the software. But back then, it was a much smaller crowd of individuals who actually helped to contribute to software. It was either researchers or engineers at top universities, government agencies, or large corporations that had the capacity to invest in innovative technology. And because it was such a tight-knit group of individuals and very academic, the way people thought about software is it was something akin to research papers. And software was something that lived in the public domain of knowledge. And essentially anyone had the ability to look at the source code of software. You can go in, you can open it, you can read it, you can understand how it works, you can modify it, and share those modifications with anyone else that you think would benefit from these contributions that you've made. Now, this would all begin to change in 1969. Prior to this, throughout the 1950s and the 1960s, IBM was the market leader in terms of hardware manufacturing. Just like everyone else, what they would do is they would develop hardware, then they would build software to improve this hardware, bundle it together, and give it away for free. And while at this period in time, people didn't view software as something that had its own distinct market value, there were several individuals who were looking to the future, and they saw the potential of what software could become one day. And they wanted to create a business around this idea. But they ran into several issues. Every time they went to sell their software to someone, they had trouble justifying why people should pay a price for something that IBM is essentially giving away for free. And this started to become a really contentious topic within the industry of technology. It became such a big issue that the Department of Justice filed a lawsuit against IBM, claiming that their tactics of bundling hardware and software and giving it away for free was stifling innovation and making it harder for these third-party software developers to compete and to form a business around software. So IBM decided to take a step back and reassess the situation. And within the same year, what they decided to do is they were going to unbundle their software from the hardware. They'd package up the software, they'd give it a price, and then they decided to let people buy that separately. And then instantly, the entire market for the entire industry for software development changed overnight, because now we had the market leader of hardware manufacturing saying that software has its own unique market value. So we started to see this shift within the emerging software development industry, where we went from this free and open and collaborative space to one where everyone else who was developing hardware kind of followed the same thing that IBM was doing, and they started to price out their software separately. More people started to get into the industry, and this created tougher competition. So the software manufacturers started to do things like release end-user license agreements, and they were no longer releasing the source code for the software they were developing. So we had a shift in how people began to develop software. Now, this started to become an issue for several people who had access to be a part of that earlier environment where software was developed in an open and collaborative space. One such individual who had an issue with this change that was happening was Richard Stallman, who was a brilliant engineer who worked at the MIT AI labs throughout the 1970s and 1980s. And he viewed this idea of free and open software as something that was a contribution to all of society. Take, for example, if I have a coffee machine and let's say that it's operating on some type of software that is a bit buggy, if I have the source code and I can go in and I can fix that bug and share it with everyone else who also has that same coffee machine, that's a public service to everyone else who's experiencing the same problem. So this change away from software being free and open and collaborative was something that was a moral and a philosophical dilemma for people like Richard Stallman. But not only was it a moral and philosophical issue, it was becoming a practical one as well. One day, while Richard was working at the MIT AI labs, they got this fancy new state-of-the-art Xerox printer. And there was a bit of an issue with this fancy new printer. It was a bit buggy, and there was scheduling conflicts that would cause it to jam. So when someone went to go and they'd try and print something, they'd type in the commands, they'd wait a little bit of time, and then they'd go and check the printer and see if what they wanted to print had come out. If someone else was trying to print something at the same time, it would get jammed and they'd have to unjam it, and then they'd go back and then they'd try and print something again. They'd wait a little bit of time. They'd go check the printer, and it turns out Janice on floor 7 in accounting was also trying to print something at the same time. So it was jammed again, and it just kept causing these headaches. So traditionally, how someone like Richard would have gone in and solved this issue is he would have had access to the source code. He would have been able to study it, and actually they had their own internal scheduler that they could use to update the software of this. Only this time, when Richard went in to inspect the source code, he no longer had access to it. And he even called Xerox and said, hey, we have our own proprietary internal scheduler, and we can fix this bug that your printer has. But they told him, I'm sorry, this is proprietary technology. We cannot give you access to it. So he's pretty frustrated about this. And some time passed, And he was actually meeting with someone at a different university. And because he was in this academic setting that was very collaborative, he thought, well, I've worked with this person in the past. Maybe they will give me access to the source code. And he asked this guy, he said, hey, you know, we're friends. We openly collaborate with one another. Can I get access to the source code to this printer? And the guy said, I'm sorry. I've already signed an NDA. I cannot give you access. So it was a moral issue. It was a philosophical issue. It was a practical issue for Richard. As a result, he set out to do a number of things to resolve this issue. In 1983, he founded the Free Software Foundation. And the Free Software Foundation, this name's a bit confusing. When you hear the term free, it doesn't mean free as in price. It means free as in like freedom of speech. The way that Richard viewed software is the same way, like if you think of the 18th century Enlightenment philosophers, and they talked about people have these inherent rights to life, liberty, and property. He thought that users of software should have inherent freedoms that everyone has. And those are the freedom to run the program for any purpose, the freedom to study how the program works and to change it, the freedom to share copies with other people, and the freedom to improve the program and release your improvements for the benefit of others. And while the free software movement made a number of technological innovations, like they created the GNU operating system, they were struggling to get traction in terms of corporate adoption of this new development method. The reason is when they went to sell these ideas to corporations, these corporations found that the messaging was too confrontational or too political, or they didn't see that there was any value for why businesses should work in this way. But this would all begin to change throughout the 1990s with the rise of the internet. With the rise of the internet, we now had the capacity to collaborate openly with anyone in the world on any project that we wanted to work on. And there were a few really early innovators who saw the potential of the internet early on. One such individual was Linus Torvalds. He wanted to create something called the Linux kernel. But he knew this was going to be a massive undertaking that one person could not build all on their own. As a result, what he decided to do, he's like, I'm going to leverage the internet. I'm going to take the source code, I will put it out there, and whoever wants to help contribute to the development of this Linux kernel, they could help me out. And soon he had access to a whole bunch of other individuals that were helping him out that he would not have access to had he been working in this closed source manner. This allowed a number of things to happen. One is he could make progress on delivering this Linux kernel much faster than he would have done if he was doing this by himself. Another thing is because there were so many diverse perspectives that were coming in and helping him out, he was able to create more innovative ideas. And because there were so many eyes on the project, they could spot bugs quicker and resolve them much faster. Now, the people who had previously worked at the Free Software Foundation, they took note of what is happening. And they said, this is really interesting. I think we have something we can sell to businesses. So, in 1998, this is what they did. They coined the term open source. They took all of that lovely messaging about free software and they repackaged it into something that was much more neutral and business friendly. And it talked about the actual value that companies would get if they adopted this way of developing software. But not only that, they created clearer guides on what it meant for software to be open source. And they provided enterprise support for any company who wanted to work in an open source manner, but didn't know how to practically implement this. A third thing they did was they created acceptance for a greater number of license types that would all fall under that open source umbrella. Fast forward nearly 30 years, and I think it is fair to say that the open source initiative has accomplished their goal. And we have a number of stats that we can point to back up this claim. One, if you look at a lot of the fundamental web technology today, whether if you're looking at web servers, hosting providers, security technology, there's a lot of open source technology that helps to run this essential web infrastructure. Another thing, prior to the open source movement and for quite some time, the Windows operating system was the most popular operating system used. Fast forward to today, we have Android, which is the most commonly used operating system, which is powered by the Linux kernel and other open source components. Additionally, there's a number of open source frameworks such as TensorFlow, PyTorch, Hugging Face that are all used by many different companies to bootstrap their AI and data science applications. And more recently, if you look at things like the open source LLMs and how they're being developed, the projects that are working in an open source manner are able to develop their large language models much quicker, and they're sometimes even better than the closed source models that are on the market. And lastly, a lot of those big corporations such as Microsoft, Google, Meta, Red Hat, IBM, Amazon, they all invest in some form and fashion into open source, whether they have their own internal projects that they're investing in or if they're investing into a third-party organization. So it's been nearly 30 years since these ideas of open source were founded. And I think collectively as an industry, we've gotten a lot of experience, and there's a number of ways which I think we can evolve best practices of open source beyond just having the source code being open. These are some of the ways that us at the input-output engineering team are thinking about this idea. One is, I believe it's essential for open source projects to not only open source their code, but you should try and open source as much of the development lifecycle as possible, including things like open roadmaps and open project boards. If you are working with a large group of people spread out all across the world, how are you going to communicate what your priorities are? What can these people meaningfully contribute to their project with? Having these open roadmaps and project boards can help people have an understanding of how can I help out with this project in a way that the maintainers will care about. Another thing that you can do as far as best practices for open source projects is to be able to surface real or near time development updates. And this allows for a number of things to happen. One is that this allows your community to appreciate all of the hard work that is happening behind the scenes to deliver these open source projects. And two, if you are receiving funding from a community or a third-party organization, this allows you to be accountable to those organizations and show that you are actually working to deliver the work that you've been funded to deliver. And then third, I don't know if you've ever worked on a development project or an open source project, and sometimes you go to their repository and it's very sparse. You have to scour the web for hours to find out where is their website, where's their documentation, and just piece all of this together yourself. It's really important to have a single source of truth where everyone can go to find all of this great information like roadmaps and meaningful insights and useful links to other resources you want them to take a look at. Input Output is a company that has a deep appreciation for open source projects, and they've been a longtime supporter of the open source movement. If you look at a lot of the repositories that Input Output has on their GitHub account, a lot of them are open sourced under either the MIT or Apache 2 license. But we want to think about how can we continue to evolve our ways of working and to double down on this commitment to working in a transparent and open and collaborative manner. And now I'm going to give you a quick demo of how we are thinking about implementing this. So what we see here, this is the development dashboard for Leios, which is a protocol that's being developed internally by the input-output engineering team. And this development dashboard, at the top, you will find there is a banner. So if there's any really time-sensitive and important updates that you want people to know about, you can display this in this banner at the top. Then we have an informational section in the header where people can just have an idea. If they land on this page and they've never been here before, we need to give them some idea of what to expect as they scroll down through the rest of the site. And as we scroll down, we get to this crown jewel of the development dashboard. Input-output is a global workforce, and we are going to be working around the clock to deliver Leios. So this section here is an activity feed where people can see development updates coming in and where in the world these development updates are happening. As we move a bit further down the page, we get to some graphs that are a aggregated view of all of the different repositories. You can see the development work as it progresses throughout the life cycle of this project. And as we move down a bit further, we have our roadmap kind of burn down chart section. So we've got these milestones, which are essentially a definition of done. And you have some type of visualization of when the work to complete the different milestones are started, an estimation of when these milestones will be closed out, and some understanding of how we are progressing towards the completion of these different milestones. Over on the left-hand side of this view, you can see a generalized view of the ticket statuses that are represented on the GitHub project board. And as we move further down this page, we've got a quick access section. So if anyone would like to know more about the actual project itself beyond the development activity, we've got a ton of really rich links that people can go to find out all of this useful information. We also have a section here for news that if anyone wants to stay up to date about blog posts and research papers that have been published, this is all available in one source. So this is a visualization of how we are thinking about implementing this. I do want to caveat this. This is all mock data that you are seeing here, but we are working behind the scenes to get ready to publish the public version of this site. So stay tuned to the input-output channels. It will be coming when we do publish it. You will have an announcement come through one of those channels. But I want to thank you, all of you kind individuals, for coming to listen to my talk today about open source. I hope that you have enjoyed the history of this story as much as I have, and I also hope you enjoy the rest of the conference. That's all, folks.